Hello and welcome to part 3 of our Rust for Beginner series. In this video, we will be learning about structures and enums. So a struct or a structure is a custom data type that lets you group up data together. It's similar to tuples, but there are a lot more functionalities and a lot more features. If you're familiar with C or C++, then you might be familiar with structures and classes. It's similar to those. Their overall look and feel is similar to that of structures, but we can also add methods to them, which is similar to classes. To define a struct, we use the keyword struct and then give a name to the struct. And then within curly braces, we define the named parameters and then the type of data it will hold. Once we have created a struct, we can create an object. Rust also has structures that look very similar to tuples. These are called tuple structs. These are useful when you want to give a whole tuple a name and differentiate it from other tuples. Structs can hold references, but for now we won't try that because it requires lifetime and that's a slightly more complex topic. One final thing before we jump to implementing these is that we can give them traits, and based on trait we can add functionalities to them. Okay, so we will create a struct for rectangle and use that to calculate everything. First, let's create a structure rectangle. It will have two fields, width and height. Both will be of type U32. Now we'll create an object of type rectangle. Give it some width and height. Now let's print the area. For now, we'll just calculate by multiplying height and width. We won't create any special function or something. We are getting area in our terminal. Let's also print the rectangle. We first need to add a trait to our struct, that is debug trait. And then when printing, we have to do colon and question mark. Good, now we are printing our rectangle as well as its area. We can also use this debug macro instead of print. So what we do is dbg and then we pass the reference to the rectangle. This will also print the value of rectangle. Next, we are calculating this currently by multiplying both of them. We don't have any special function. So let's create a function for this. But first, we'll create an implementation block for rectangle. Within this, we can create functions that can be called from the object rectangle. So we'll do fn area and it will take a parameter self and it will return a value of unsigned integer. And then we simply move the multiplication inside the function. So it will be self.height into self.width. And that's all. We have the area of rectangle. So we'll do rect.area and we should get our area here now. And yes, we are getting our area. It's not necessary to keep a single function within an implementation block. We can add as many functions as we want. So we'll create a parameter function as well. Same thing. Let's print the parameter as well. Okay, now we also have parameter. Okay, next thing we want to check out is that we don't actually need to create a single implementation block. We can have any number of implementation block. So let's create another implementation block for rectangle and create a function. So we'll create a function is square. Same as last time, it will take self as a parameter and return a boolean value. And we'll just return if our height is equal to our width or not. So we can have any number of implementation block as we want. This allows us to add functionality to structs predefined within Rust. Okay, so this is working fine. We are getting true and false based on height and width. Now let's take the height and width from the user and then use that in our object. Okay, so we have taken height and width input. Now we'll create two variables named same as the parameters within our rectangle, height and width. So basically what I'm saying is the parameter name should be same as the field within the struct. So since we have height and width, so we have created two variables, height and width as well. We have passed it into U32. For now, I'll pass width in height and height in width because I want to show you a shorthand. So first we'll do this. We'll run this code. Let's enter height 12 and let's say 6. Okay, we are getting a panic. Let's see what's the problem. Okay, so we haven't trimmed height and width before passing it. That's why we are getting this error. Okay, so here you can see we have given height 45 and width 12, and we are getting width 45 and height 12. Passed height in width and width in height. But we can also just remove this named parameters from here. We can just leave the variable as is. And if we do that, the Rust will check the name of the variable and match it with the field within the rectangle. So the value of height variable will be stored within the height parameter of the rectangle and width will be stored within width. So this time you can see the width is what we entered within width and height is what we entered within height. So enums also allow us to create a data type just like structs. But unlike structs where we have a specific number of parameters, enums gives you a way of saying that a value is one of these possible sets. Like in this example, we have an enum for IP address. So IP address can be either v4 or v6. To create an enum, we just use enum keyword and then within curly blocks, we define the possible values. Once we create an enum, it can be used as any other data type and we can also pass it as our data type within structs. To store the value within an enum parameter, we just use the name of enum and then with double colon, we pass the value that we want to store. Each value within enum can also have a specific data type to them. This is an example where we have v4 and v6, but they are of type string, so they can hold string values. And this is also an example where we have used u8 tuple instead of string. So we can store any type of data within the values of enum as we want. We can also create like structures within the value of enums. In this example, we have network ID and host ID, two named parameters within v4, each having a different data type. Okay, so let us suppose that we are creating some code for DNS server, and we need to handle DNS record which has a domain and its mapped IP address. So let's create a structure for that. It will have domain and IP address as its two parameter. We'll also add one more IP address type because the IP address can be v4 or v6. And for that v4 or v6, we'll create an enum. So this is our simple enum IP address. Let's add this to our DNS record. And let's also add debug traits so that we can print them when we want. Now let's create an object of this structure. For IP type, we'll do IP address, which is our enum, and then we'll use double colon and then the type, which is v4 in this case. Okay, so this object is ready. Structure looks good, so we'll run this and see what we get. We are getting a DNS record which has domain OptiCode and IP address v4. Now let's remove this IP address string. Instead, we'll have IP address of type IP address enum. This is also because we can store data within enum values. So we'll give a type to v4. In this case, I'll give u8, u8, u8. We have seen this in example. This way I can store a tuple of 4 u8s within v4. And yes, we are getting our tuple. Now let's also give a type to v6. We'll just give string for now, but we'll create more complex types in a second. Now let's also create an array. We currently have just single record. We can create multiple variables, but it's better just to create an array. Let's make 3 elements within the array. Okay, now we have our array and we have 2 IPv4 and 1 IPv6. Now currently we have this single string within enum for v6. Let's make this slightly more complex by, instead of just using a single string, passing named parameters. So we'll do routing prefix, subnet ID and interface ID. So this might look very familiar because it's very similar to a struct. Just like struct, we can pass named parameters and we can store value in them. Now here we'll remove this string and pass the named parameters. Everything works fine. Next, we'll add another feature which is same as structs, which is implementation block. Just like structs, we can create implementation block within which we can associate certain functions to enums. So in this case, we'll do fn get address as string, with self as input parameter, and we will return string from this function. Now here we need to create a match condition because we have multiple values within enum, and for every value we must return something. So we'll do match and then we'll do self v4. This will be for v4. We'll simply format this into an IP. And this will be our return for v4. Next, we need to do the same thing for v6, but instead of, let's say, taking a, b and c, we'll take variables like routing prefix, subnet ID and interface ID and change the format based on those parameters. So now we can call this get address as string function on both v4 and v6. In v4 it will combine it with dot, and in v6 it will combine it with colon. Let's change this for loop a little bit. We'll make it DNS record. I will do IP address and then we'll call the function get address as string. Let's also print the domain, otherwise we won't know for which domain we are printing the IP. Okay, great. We have two types of IP address printing. One is IPv4 and the other one is IPv6, and both are in the correct format. Now, one more thing I want to show is option enum. The option enum allows us to store a certain type of value as well as none within a single type of parameter. Currently, we can't store anything other than, let's say, string in domain, IP address within IP address. So we'll create another field which is optional IP address, and in that we'll give a type of option. This will allows us to store either a certain type of data or none values. It's a generic, so it can take a type. We'll give it IP address as a type. So now let's suppose our website on our main IP address is not working, so we can provide an optional backup IP on which the user will be redirected. Now let's add this optional field to our DNS records. So we need to pass the value within sum, If we pass it directly, it will give us error, and basically won't take it. We'll say pass it within sum. We can pass the value either in sum, or we can just pass none. Okay, so now we can obviously print a none value, but if we are doing some operation and we use none, then we can get an error. So let's see a way so that we don't get any error even if we are using option and it has none. Let me also put some print line blocks to create some space. The two main ways is, one, we use a match statement. So we'll do a match optional backup IP, and then we'll pass our IP address within sum and then within the print statement. And for none, we do nothing. And now we can see our optional IP as well. Let me copy this print block within the for loop as well. It will create some space between all the print statements. Okay, so this was the first thing. We can make this slightly smaller, not a lot, by using either unwrap or some variation of that. So unwrap allows us to open option enums. So we'll do DNS optional backup IP and do unwrap. So if we do an unwrap on none, we get an error. As you can see, we are getting an error here because I did unwrap and called a function, even though the unwrapped value was none in the second element within our array. But there are variations of unwrap like unwrap or, in which we get a default value, so we don't get any error. So I can do unwrap or here. If I do unwrap or, I can pass a default value. Generally, I do this to pass string. But in this case, if I pass a string, then we will get an error because we have a function called get address as string after we unwrap. So we need to pass an default enum within the unwrap or statement as well. So let's simply create a new variable, optional ID. And here let's just copy an enum of IP address and paste within the default block. Okay, now if we have none, it will return this default IP address. So here we can see that we are getting 0.0.0, which is what we passed within the default of our unwrap OR. This covers everything for structs and enums. Thanks for watching. Please give a thumbs up and do consider subscribing.